What's up, guys? It's day 73, I think. I don't know. Pretty sure. Of the 100 Days of LeetCode, we got an easy problem, number 234, Palindrome linked list. So we are given the head of a singly linked list, and we want to return true if it is a palindrome. If you've watched some of my problems before, we've done some palindrome problems, but basically what a palindrome is something that's the same backwards as it is forward. So 1, 2, 2, 1 is the same because it's 1, 2, 2, 1 from the other side. 1, 2, of course, is not, because 1, 2 is not equal to 2, 1, so it's false. Okay. So our approach today to solve this problem, what we're basically going to be doing is we're basically going to be finding the midpoint of the list. We're going to be reversing the second half of the list, and we're going to be checking whether or not the second half is equal to the first half. And if it is, we have a palindrome. If it is not, we don't have a palindrome. So we're going to return false. Okay, so let's do that. The way we reverse the list is we're going to create basically a slow pointer, a fast pointer, and they're both going to be set equal to head. Okay, and head, of course, is passed in as a parameter. That's the first node of our linked list. Okay. So what we're going to do is we're going to do, well, fp and fp.next, basically while these two nodes are not null, or not none, I guess, because it's Python, we're going to be doing fp equals fp.next.next, sp equals xp.next.next. Or, sorry, just one next for sp. And the reason why we're doing that is because basically we want to advance fp forward 2 nodes each time, whereas sp is only advancing forward 1 node. So by the time this returns false, sp will be around the midpoint. And I say around the midpoint is because if you have an even linked list, there is no official midpoint. But yeah, that's how we're going to split the list in half. Now, once we do that, we're going to create a node called second head, and right now we're going to set it equal to none. So this second head is basically going to be at it's going to end up at the end, or at the beginning, I should say, of the reversed second half. And then after that, we're just going to compare whether or not all the nodes of the list are equal. And if they are, the nodes of the first half and the reverse second half, then we know we have a palindrome of a linked list. Okay, so now we have to write the code to basically reverse the second half of the linked list. There's a famous LeetCode problem that I haven't done on this channel actually, but it's reverse linked list, and this is basically going to be pretty much the same code as the code from that. It's going to be the iterative solution for reversing a linked list. So yeah, we're going to do that problem right now. So to reverse a linked list, what we need to do is we need to essentially reverse the links between here. And then the head is slowly going to be moving over to the right, and at the end of it, the head is going to point to the last item, and all the links are going to be reversed. So if we reverse the head, it's basically the reversed version of the linked list because all the nodes are reversed, all the links, excuse me, are reversed. And yeah, that's pretty much what we're doing. Now, how do we do that? Okay, so let's write our loop. Oops, there we go. While the slow pointer, right? So basically, while the slow pointer isn't none, we're going to keep this loop going. First thing we need to do is we need to save the slow pointer's next value, okay? And it's the reason why we're doing this initially is because in the next line, we need to basically change the slow pointer's next value to our second head, okay? So let's say we're reversing the link between 1 and 2. 1 can be our slow pointer for right now, okay? So we need to save its next value, which is of course is 2, and then we need to take the next value of this one and set it equal to our second head. Right now our second head is equal to none, so right now our second head is not, or our sp.next is none. Okay, now we need to basically switch our second head to be equal to slow pointer. Okay, so like I said, slow pointer was now equal to 1. So that's going to be our second head now. And then what we're going to do is we're going to, basically set SP is equal to the next. Okay, so remember at the beginning this was set to the next. So now the net effect is that our slow pointer shifted over 1 to the right, okay? And our second head is now this node. This while loop goes until SP is equal, has a value, right? When it's none, it won't have that. So this is going to keep shifting until eventually our SP is over here at a none value, because this node's next has a none value. And then our second head is going to be at the end of the list. And that, of course, is what we want. Now, when I was explaining how to reverse that, I was sort of speaking in terms of an entire list. But again, it's important to remember that we're only reversing the second half of the list in this problem because of what we did up here. So now what we need to do is we have that code. That's fine. We need to say while second head. And we need to check whether or not the second head.val is equal to head.val. And if they're not, we're going to return false. If they are, what we're going to do is we're going to say second head.next, second head is equal to second head.next. So we're going to move that one forward, or in this case, backwards, right, from the end of the list. And then we're going to move head is equal to head.next. And then if we get through that while loop without, having any problems, we're going to return true. And that should be our code. There you go. So that's how you solve that one. If you guys enjoyed that video, please like, subscribe. Today was day 73. We got another 27 days to go. So, yeah, that's it. Take care.